In this article, I'm going to talk about base class library, common language runtime, and common intermediate language. And also, I'm going to give you some information about .NET assemblies. But let's see what I will cover in this video. First of all, I'm going to introduce the building blocks of the .NET platform, such as CLR, CTS, and CLS. And then I'm going to talk about more about base class library. We are going to find out what managed and unmanaged code is. Then we are going to find out an overview of .NET assemblies, which will cover the role of CIL in .NET framework, what ILDASM.exe offers, and then benefit of CIL or Common Intermediate Language. Then I'm going to talk about JIT or Jitter compiler in .NET framework. Then I will cover the rule of .NET type metadata, and the last one is the rule of assembly manifest. So, beforehand, let's take a look at framework class library, and which is abbreviation of FCL, in which you can see so many other classes, functionalities, and other services. And this article cover base class library, common language runtime. So as you can see, there are lots of things in a framework class library which you want to code something like Windows Phone, WPF, or creating or developing Xbox video games, and also desktop application. Or if you want to develop web forms such as MVC and Ajax or ASP.NET web form, you can use a framework class library too. So I will in this video just cover base class library and common language runtime. So, introducing the building blocks of the .NET platform, the CLR, CTS, and CLS. Now, you have understood some benefits provided by .NET framework, which you have learned in previous videos. I'm going to describe three key topics that will help you to understand the key benefits better. The first one is CLR or Common Language Runtime. As a programmer point of view, .NET could be a runtime environment and a comprehensive base class library. The runtime is referred to as Common Language Runtime. The main goal of CLR is to load, locate, and manage .NET objects on the programmer's behalf. It means that CLR always handles these operations. Also, CLR take care of memory management, application hosting, and some security checks and coordinating threads. So, what about Common Type System or CTS? The CTS describes all data types and all related constructs, which supported by runtime, details how they would be represented in .NET metadata format, and also it specifies how entities can interact with each other. So in other words, we have several languages, and each language has own data type definition and cannot be understandable by other language, but CLR can understand all the data types. For example, C# has int data type, as you can see here, and also VB.NET has integer data value. So we have two programs in here which has developed by C# and VB.NET. And as you know, int is data type for C# and integer is a data type for VB.NET. So each one has own compiler, C# compiler and VB compiler. So after compilation, it uses the same structure as int32 in CTS. As you can see, after compiling or compilation of each programming language, we will have actually the same thing, the same structure in CTS. So, what is Common Language Specification? CLS is a subject of CTS. It defines a set of rules and restrictions that every language must follow, which runs under .NET Framework. For example, imagine you develop an application by C# and VB.NET. In C#, every statement must have to end with semicolon, otherwise in VB.NET shouldn't be written like that. So these syntaxes rules are different from languages to languages, but CLR can understand all languages syntaxes. Because in .NET, each language is converted into MSIL. So as you can see, there are some abbreviation in here, MSIL or CIL or even IL, which respectively stands for Microsoft Intermediate Language, Common Intermediate Language, and Intermediate Language. So these syntaxes rules are different from languages to languages, but CLR can understand all languages syntax because in .NET Framework, each language is converted into MSIL code after compilation. And MSIL code is language specification of CLR. So as you can see, Common Type System is a subset of Common Language Runtime, and also Common Language Specification is subset for a Common Type System. So Base Class Library. BCL stands for Base Class Library and also known as a Class Library or CL. BCL is a subset of Framework Class Library, which you saw it in the early of this video, and Class Library is a collection of reusable types that are closely integrated with CLR. Base Class Library provides classes and types that are helpful in performing day-to-day operation. For example, dealing with string and primitive types, database connection, and I/O operations. BCL defines types that can be used to build any type of software application. You can use ASP.NET to build websites and REST services, WCF to build distributed systems, WPF to build desktop GUI applications, and so on. As well, the base class libraries provide type to interact with the dictionary and file system on a given computer, communicate with its relational database via ADO.NET, and so on. So, what are managed and unmanaged code? Now that you have understand the definition about BCL and CLR, I'm going to talk about managed and unmanaged codes. C# language can be used only to build software that is hosted under .NET Runtime. The term used to describe the code targeting the .NET Runtime is managed code. There's a binary unit that contains the managed code, which is called assembly. In contrast, codes that cannot be directly hosted by the .NET Runtime is called unmanaged code. As I mentioned in previous article or in previous videos, the .NET platform can run on a variety of operating systems. It is possible to build a C# application on a Windows operating system using Visual Studio and run the program on a Mac OS and using the .NET Core runtime in that. Also, you can build a C# application on Linux operating system using Xamarin Studio and run the program on Windows, Mac OS, and so on. The latest release of Visual Studio, Visual Studio 2017, we can also build .NET Core application on a Mac machine and to be run on Windows, Mac OS, or Linux. It is possible to build, deploy, and run .NET programs on the different operating systems too. An overview of .NET assemblies. Regardless of which .NET language you choose to develop after compiling your application, there would be two types of assemblies: executing files or exe file, and dynamic link library or DLL, as you can see here. So what is MSIL? When we compile our .NET program, it is not converted into the executable binary code, but to an intermediate code called MSIL or IR, which is understandable by CLR. MSIL is an OS and hardware independent code. When the program needs to be executed, this MSIL intermediate code is converted to binary executable code called native code. All the .NET assemblies contain the definition of types, versioning information for the type metadata, and manifests, and in this video I am going to talk about it more. If you have a class named customer, the type metadata describe details such as customer's base class, specifies which interfaces are implemented by customer class, and also gives some information of each member in customer class. .NET metadata also presented within an assembly, and it is .NET duty to automatically generate it. CIL and type metadata assemblies themselves are also described using metadata, which is called manifest. The manifest contains information about the current version of the assembly and a list of all externally referenced assemblies that are required for proper execution. So in the following video, I am going to use a tool to examine an assembly type, metadata, and manifest. So the rule of CIL in .NET Framework. To understand the rule of CIL, take a look at the following C# code, which models a calculator. Don't worry about syntax. I will cover any single code in this course. So as you can see, we have two classes, program class and calc class. Program class, which is the app's entry point, and calc class, which has a method named addNumbers and add two numbers and return the result of adding numbers here. So after compiling the application using C# compiler, you will end up with a .exe file that contains a manifest, metadata, and CIL. To understand it better, let me go to the location I have created my simple application in bin folder, in debug folder. Here I have a calculator.exe in here. So now let's use ildasm.exe to examine our calculator exe file. So to find ildasm, just follow the folder and paths that you can see right here, and I will open it up. So let's go. So as you can see, here is the location of my ildasm.exe. So I think you can find more ildasm.exe in your actually folders and locations of your I think C drive maybe. So here's the path of my ildasm.exe. Here we go, and I double click on it. Here we go, ildasm. So if I want to open my simple application, I can go to file menu and open it, or I can go to the location of my application here and drag and drop calculator.exe right here. So can I use it in as an external tool in Visual Studio? Yes. So let's close the application, or let's close the tools and go to Visual Studio. So you can go to tools menu. Here we go. We have an external tools right here. So click on add. Name the title. I will name it ildasm. So in command text, you just need to open or paste the path of ildasm exe file. So let me go to here. I will copy it and then go back to Visual Studio. Here we go. Do not forget to write down the name of ildasm.exe file, ildasm.exe here. So in argument, click on the right arrow button right here and choose target path. And do not forget to check close and exit. Apply and OK. So beforehand, let's see what ildasm.exe file offers. It will show you three basic things: a list of classes and methods in your assemblies, the contents of the assemblies manifest, and intermediate language code for any method implemented in the assembly. To open related assembly, just go to Tools menu here. So I have added ildasm. Just open it. And here we go. As you see, there are some information about assembly type, manifest, and metadata. If I expand calculator right here, I have two class, as you can see here, and we have two class right here, program class and calc class. So if I expand calculator.calc, there would be add numbers method right here. And by double clicking on the method, I can see the information about this method in a new dialog box. Right here. Pay attention here to int32 data type. As you remember, in early of this video, I talked about CTS or command type system, in which all of data types after compilation would be understandable for CTS. Therefore, int in C# or integer in VB.NET will be compiled as int32 in CTS. So as you can see, the add numbers method is represented using CIL as above here. CIL. So what is the benefit of CIL? Now you have understand the definition of CIL, and you understand what exactly it does, why it is necessary to use or to compile your code into CIL. Do remember, as I said, you can use variety of languages in .NET framework such as VB.NET, F#, C#, and so many other things. Here is the benefit of using CIL. No matter which language you use in your project, maybe one or more, maybe two, and so forth. And at the end, all of them will compile into CIL, and all of languages will interact within a well-defined binary arena. So, JIT compiler in .NET framework. The JIT compiler is an important element of CLR, which loads MSIL on target machines for execution. The MSIL is stored in .NET assemblies after the developer has compiled the code written in any .NET compliant programming language, such as Visual Basic or C#. JIT compiler translates the MSIL code of an assembly and uses the CPU architecture of the target machine to execute a .NET application. As the jitter compiles CIL into related machines code, it will cache the result in memory to target operating system. For example, if a call is made to method named addNumbers, the CIL on the first invocation will be compiled, and it will be retained in memory for later use. Therefore, the next time addNumber is called, there is no need to compile the CIL. So let's talk about the rule of .NET type metadata. .NET assembly contains complete and accurate metadata such as class, structure, and also members of each type such as properties, methods, and etc. So, how these information extract? By programmer or by compiler? Hopefully, all of these tags done by compiler, not the programmer. To show you the format of the metadata, let's take a look at our project metadata generated by the add numbers method. To do that, simply open ILDSM in your tools as I opened it earlier. And after dialog box popped up, just hit Ctrl plus M. So let me close it here. Just hit Ctrl plus M to illustrate the type of metadata of your project, or you can go to View menu, Meta Info, and click on Show. So if you hit Ctrl M and dialog box disappear, make sure to open proper ILDASM.NET Framework version. If your project is generated by .NET Framework version 4.6.1 and you open ILDSM with .NET Framework 4.5.1, your dialog box will disappear after using Ctrl M keyword. As you see in the in this window, in this dialog box, we have type def2 right here, which provides some information about the project. For example, type def name refers to calc class in our calculator project, and there are two methods in calc class. Add numbers, which takes two parameters x and y here, which has x and y parameter, and .setter, which is default constructor of calculator class or calc class and generated automatically by .NET Framework right here. Don't worry about methods and constructors and default constructor. I will cover all of them in next videos. I'm just here to show you a little bit about what assemblies are doing in our application. So the next one is the rule of the assembly manifest. .NET Assembly, which contains metadata that describe the assembly itself. As I mentioned earlier, it is called manifest. Manifest documents all external assemblies information, such as assemblies version number, copyright information, and so on. So accordingly, it is compiler duty to generate assemblies manifest rather than the programmer. So thanks for watching and see you on next video.